Good day, students. On this clip, we're going to be going over 5 questions on probability that involves choosing a group out of choosing a subgroup out of a bigger group, which definitely involves the use of combination here because we're going to be doing some kind of selection or choosing. All right, so let's take a look at the first question, question number 1. Which reads, it says, what is the probability of picking 3 boys from a class with 5 girls, 21 boys, and 2 adults? All right, so basically we know what probability of an event is. Probability of an event is probability of success, we know, is basically success over success plus failure. So, probability of being successful, so basically probability of having 3 boys is going to be a selection that guarantees success. So basically it's going to be number of ways you can choose out of 21 boys, choose 3. If you choose 3 out of 21, you're guaranteed to be successful because all these are all boys. So if you pick any 3, you're guaranteed to have boys. Okay? So this is success, and then success plus failure will go on the bottom. So success plus failure means boys and every other thing else. So what is that? That's going to be 5 for the girls plus 21 for the boys plus 2. Okay, failure is girl or adult. Success is boy. So we add everything together, you get success plus failure. We add 5 plus 21 plus 2. That's 28. So that's going to be 28. So it's going to be number of ways you can choose. Out of 28, which is success plus failure, you choose 3. Okay? So this is your setup for solution to the problem. Okay, and then you can apply, you can also write it, same thing, you can write it as 21C5 over 21C3, where did 5 come from? 21C3 over 28C3. Alright, and then you can apply the probability formula. You know NCR is basically n factorial over n minus r factorial times r factorial. So in this case, it's going to be 21 factorial over 21 minus 3 factorial, 3 factorial. That's probability of successful outcomes over successful failure on the bottom, which is 28 factorial divided by 28 minus 3 factorial, 3 factorial. And then basically work these two out independently, and then you divide your answers, and that will give you the result. Okay. All right. Let's go ahead and try another example. Number 2. It says, what is the probability of selecting 2 Cokes and 3 caprisuns from a container containing 5 Cokes and 7 caprisuns? So we know probability of success again is success over success plus failure. Alright? So probability of selecting 2 Cokes and 3 caprisuns, we're going to be doing 2 probabilities. So whenever you have 2 probability, the keyword here is and. Whenever you have and, that means you're going to be multiplying probabilities, okay? So in this case, to be successful, how about to be successful selecting the Coke? To be successful selecting the Coke, you're going to be choosing out of just Cokes, which is 5, you're going to be choosing 2. This guarantees success because there are only 5 Cokes. Alright, times, for 3 caprisuns, how many caprisuns are there? Choosing out of 7 caprisuns, you're choosing 3. Okay, so this is probability of this is success on the top right here. Alright, and the number of ways to be successful and to be a failure, we're basically going to do the total. What is the total amount of things we have in a cooler? 5 plus 7. So it's going to be C of 5 plus 7, which is 12, comma, how many selections are we making? We're making 2 Cokes and 3 Capri Sun selections. So 2 plus 3 is 5. Okay? Another shortcut you can use is the first ones, the ends. 5 plus 7 is 12, 2 plus 3, 5. And there goes your final answer. Okay, so this is your answer. You can also write it as 5C2 times 7C3 divided by 12C5. Alright? And then you can work these individual probabilities independently, and then you get your answer and divide it. Alright? So there you have it. Now let's try another example. It says, what is the probability of picking 3 iPhones and three iPhones from a box containing 4 iPhones, 7 Androids, and 3 sidekicks? Alright, so this is just one selection here. We're not selecting 3 different items, just selecting one kind of item, which is an iPhone. Okay, so in this case, probability of success again is equal to success over success plus failure. So probability of selecting 3 iPhones. What you do here is you have this number of ways of choosing to be successful on the top. So we're choosing out of 4 iPhones, we're choosing 3. This guarantees success because they're just 4 iPhones. If we choose 3 out of the 4, we're guaranteed to be successful. Okay, over success plus failure. Success plus failure means out of everything we're going to choose 3 phones. So what is everything? 4 plus 7 plus 3, which is 14. So out of 14, we're going to choose 3. So there goes your answer. And then that is the same thing as 4 choose 3 divided by 14C3. Okay? Alright. Now moving along, let's try another example. It says, what is the probability of picking 2 Ferraris and 6 Bentleys from a luxury auto shop with 14 Ferraris, 7 Bentleys, and 13 Bugattis? Alright? So this is a combined probability because we have the keyword here and. Alright, so let's do this. So we're going to go, probability of success equals success over success plus failure. Alright? So probability of 2 Ferraris, and 6 Bentleys is going to be given by number of ways you can be successful. So how many ways can we be successful? Successful means we're going to be choosing just Ferraris. So how many Ferraris are there? There are 14. So out of the 14, if I choose 2 Ferraris out of just pure 14 Ferraris, I'm guaranteed to be successful. And for the Bentleys, how many Bentleys in all? 7. If I'm choosing just 6 out of the 7, I'm also guaranteed to be successful. Alright, now I'm going to divide it by the ways I can pick a total of 8 cars, okay? So how many cars are there in all to begin with? We're going to add everything, right? We're going to add 14 plus 7, which is 21, plus 13, which is 54. So out of 54 cars, I'm choosing, how many cars am I choosing? 2 plus 6, 8. This is success plus failure, and this is success. So there goes the setup for your selection here. You can also rewrite this as 4 choose 2 times 7 choose 6 divided by divided by, we use a ruler here, divided by 54 C8 is just another way. Apply the formula here, and all each and every one of them and divide, and that'll give you your final answer. Alright, let's take a look at the next example. It says, what is the probability of pulling 2 snakes and 3 crickets from a hole containing 12 snakes and 4 squirrels? So, let's take a look at this. We know probability of success equals success over success plus failure, okay? So how can we be successful here? So probability of probability of 2 snakes and 3 crickets. Interesting what we have here. We're gonna have to be successful with the snakes. We're gonna choose. Oh, we're gonna choose out of 12. We're gonna choose 2. Right? This is for the snakes. And means you multiply, right? And means we're gonna choose out of how many crickets are there in the hole. Wait a minute. The hole has no crickets in it. So if their hole has no crickets in it, it's impossible for us to have any crickets chosen. So guess what? This is going to be 0. This is going to be 0, which makes the whole problem 0. So in this case, the probability is simply probability is equal to 0. Okay, since there are no crickets in the hole, there is no chance you're going to have any crickets. You can have some snakes, but no crickets. But it says and, so this has to be considered. So in this case, your probability is 0. Alright, so that's that. I'm going to give you some problems to look at. Hopefully this presentation helped you.